Good morning, guys. I'm going to do an example of this t-test for independent means hand calculation for you. I'm going to upload this handout and I will post this as well just to walk through each step so you can see how to do a t-test using the deviation score method. Again, this is based on everything you did with learning how to compute the standard deviation. So with the independent means, we have two different groups. So here we have your experiment group and your control group. Each group has a set of scores, 1, 2, 3, 4, 5, 6, 7. So your N is 7 for each group. So here, so for the sum, you would add all these scores up. You get 42. 42 divided by 7 gives you 6. So that is your mean for group 1. Your mean for group 2, if you add all these up, you get 21. 21 divided by 7 is 3. So your mean for group 2 is 3. 21 divided by 7 is 3. Okay. The next thing we do is you take the deviation from the mean. So that means you subtract the mean score for that group from each score. So here your mean was 6. So 6 minus 6 is 0. 4 minus 6 is negative 2. 9 minus 6 is 3. 7 minus 6 is 1. 7 minus 6 is 1. 3 minus 6 is negative 3. 6 minus 6 is 0. When you sum these again, just like for the dependent or your one sample, this deviation should always equal 0. If not, you've made an error over here. So this deviation is 0. That means you sum all those up, you get 0. Because we know negative 3 and 3 is 0. 1 and 1 is 2, so 2 minus 2 would be 0. The next step is the squared deviation. So you square each of the deviations. So 0 squared is 0, negative 2 squared is 4, 3 squared is 9, 1 squared is 1, 1 squared is 1, negative 3 squared is 9, 0 squared is 0. Okay, next you sum these. So sum the deviation. That sum is 24. Okay. So for your population variance, this S squared 1, you take the sum of the squares, which is 24, divided by n minus 1. Here n is 7, so n minus 1 is 6. So 24 divided by 6 is how we got this here, and that is equal to 4. So that is your population variance. So population variance for group 1 is 4. Population variance for group 2, we come over here to find that. Again, same steps. You subtract the mean from the score, 6 minus 3, because our mean for group 2 was 3. 6 minus 3 is 3. 1 minus 3 is negative 2. 5 minus 3 is 2. 3 minus 3 is 0. 1 minus 3 is negative 2. 1 minus 3 is negative 2. 4 minus 3 is 1. You sum those again, you should get 0. If you haven't, check your calculations. Then you square those deviations. 3 squared is 9. Negative 2 squared is 4. 2 squared is 4. 0 squared is 0. Negative 2 squared is 4. Negative 2 squared is 4. 1 squared is 1. You sum all those up, you get 26. So our population variance, S squared, S sub 2 squared, is your population variance for group 2. That's 26 divided by n minus 1, n being 7. So 7 minus 1 is 6. So 26 divided by 6, you get 4.33. So that's the population variance for group 2. Okay, Here shows your N. Your N for group 1 is 7. Degrees of freedom is N minus 1, so 6. Same thing for group 2. Your N is 7. Degrees of freedom is going to be N minus 1, so 6. Here, your total degrees of freedom is degrees of freedom from group 1 plus degrees of freedom from group 2. So 6 plus 6 is 12 because the N minus 1 gave us 6 for both groups. Okay? Moving down for that, and I've written down here at the bottom what these mean for you so you can keep up with that. So M sub 1 is mean 1, M sub 2 is mean 2. S1 squared is the population variance for group 1. S sub 2 squared is the population variance for group 2. S squared with the M1 is the variance for sample 1, and then this would be variance for sample 2. And then your S sub P squared is your population variance. Okay, so here, looking at the population variance, you're going to use the values you've found. Degrees of freedom for group 1, which is 6. Degrees of freedom total is 12. S sub 1 squared sorry, I got distracted. The S sub 1 squared is going to be 4. This is where you got right here. Okay. Then the same thing for group 2. Degrees of freedom was 6. Total degrees of freedom was 12. And your S sub 2 squared is 4.33. Remember, that's your population variance. So 4 is population variance for group 1. 4.33 is population variance for group 2. So now when you calculate that, 6 divided by 12 is 1/2 or 0.5. Multiply that times 4. So 1/2 times 4 is 2. And 1/2 times 4.33 is 2.17. You add those together and you get 4.17. So your population variance is 4.17. Okay? Now, the variance of the sample here, you take that 4.17 you just found and you divide it by the big N, which is 7, because you have 7 values in your group 1 and 7 in your group 2 over, so it's your big N. So 4.17 divided by 7 is 0.6, and 4.17 divided by 7 is 0.6. These two will always be the same. Okay, so those should give you the same values because you're using the same 4.17 or the population variance for each, and then your N's should be the same for each. So these values should always match also. Now for the S difference, so this is the estimate of variance of the sample distribution. So you take these and add them together. So you have 0.6, 0.6, you get 1.20. Okay, 1.20. So this is your variance. Okay, the estimate of the variance. That's the variance. Now, to find the standard deviation, you take the square root of that. So this S difference, this is going to be your standard deviation. So you take the square root of the 1.20 and you get 1.10. So that's the standard deviation for your sampling distribution. And it's also known as the standard error. All right, now if you use the t-test, and we're doing it by hand, we have to use the t-table. So we've got to figure out what t-value we need in order to be able to accept or reject the null. So we have 12 degrees of freedom. We're going to be using an alpha level of 5%, which is 0.05. This is going to be two-tailed because we only want to know if there is a difference between the two groups. So if you look on the t-table and you look 12 degrees of freedom at the 0.05 level, you're going to see a t-value needed to reject the null is 2.179. So you should be able to find that on your t-table. All right, so you would look up 12 degrees of freedom in the column. At the top, look at the 0.05 level. We're looking at two-tailed. And that value you should find is 2.179. Okay, so now we have to calculate the t-value obtained. We only found the standard deviation so far. So to find the t-value, you're going to take your m sub 1 minus m sub 2. All right, so your mean 1 minus mean 2 divided by the standard deviation. So the mean for group 1 right here is 6 minus the mean for group 2, which was 3. So 6 minus 3 divided by 1.10. So we get 3. 6 minus 3 is 3 divided by 1.10, and that gives us 2.73. So here's where the last step of the 5-step, you compare your t-value obtained to your t-critical. And here, because our t-value obtained exceeds or is larger than, greater than the t-critical, we can reject the null. This means that there is a significant difference between our two groups being tested. Okay, so because t obtained, the t we found, calculated, 2.73 is greater than, it's bigger than 2.179, we can reject the null. This means there is a significant difference between our two groups. So now you can see how we had to find the standard deviation in order to calculate the t-value. Okay, so you find the means of each group, and then you use the standard deviation method to calculate the standard deviation, and that gives you your t-value. I hope this helps, and I will talk to you soon. Have a good day.